Pressure is the force per unit area. So, if the same force acts on a larger area, the pressure will be smaller. If a larger force acts on the same area, the pressure will be larger. You can use the sliders to check the different combinations. You must have used a knife to cut a slice of butter. Imagine you try two knives, one sharp and the other blunt, and apply the same force on each. You find that you can cut easily with the sharp one. This is because the sharp one has less surface area, so the pressure increases and it cuts easily. Try moving the hole in the glass above and below the original position. When the hole is moved higher, you will notice that water flows out with less pressure. When the hole is moved lower, the water flows out with higher pressure. This shows that pressure increases with depth. As the diver goes deeper into the water column above him keeps increasing. So, the total pressure on him is the sum of the atmospheric pressure and the pressure due to the water column above him. The atmospheric pressure remains constant, but the pressure due to the water column keeps increasing. Pressure increases with depth. So, the pressure due to the water at the bottom of the dam is greater than the pressure due to the water at the top of the dam. If the wall is narrow at the bottom, it will not be able to withstand the water pressure. Therefore, the lower portion of the dam is made broader. Pressure does not depend on the shape of the vessel. It only depends on the height. So, in all the vessels at the same height, the pressure will be the same. Try moving the line joining A, B and C upwards and downwards. According to Pascal's principle, if there is any increase in the pressure in a fluid in a closed container, the pressure will be equally transmitted in all directions. Let us consider three plugs in the container A, B and C, with A having the smallest cross-sectional area and C having the largest. This figure represents the top view, where A, B and C are at the same depth. When the pressure is increased, according to Pascal's principle, the pressure gets transmitted equally in all directions. So, the pressure on A, B and C will be identical. But force is pressure times area. So C will be subjected to the largest force since it has the largest area. Pascal's principle can be applied in lifting heavy loads using a much smaller force. If you wanted to lift the truck, you can apply a pressure at some point in the fluid. This pressure will get transmitted to the piston holding the truck, which will force the truck upwards. By changing the slider, you will notice that by increasing the base of the piston holding the truck, you can apply a lesser force to lift the truck. But remember, the more you increase the area of the piston of the truck, the smaller the distance you can move it up by. Buoyant force is a force which acts on a body immersed in a fluid. It depends on the volume of the body submerged in the fluid. If the body is submerged partially in the fluid, the buoyant force is less than when the body is submerged fully in the fluid. Buoyant force does not depend on depth once the body is fully submerged. So, if it is fully submerged near the surface or the bottom, the buoyant force remains the same. The magnitude of the buoyant force is the amount of fluid displaced. Take equal volumes of wood and steel and put them in water and collect the water displaced. Now weigh the water displaced. You will see that the water displaced by the wood is less, since part of it is not submerged, and hence the buoyant force is less. The water displaced by the steel is more, since all of the steel sinks, and hence the buoyant force on the steel is more. The magnitude of the buoyant force is the amount of fluid displaced. Take equal volumes of wood and steel and put them in water and collect the water displaced. Now, while sinking, as more of the body submerges into the liquid, the buoyant force keeps increasing. The moment the entire body has submerged into the water, the buoyant force has reached its maximum value. From here on, up to the bottom of the tank, the buoyant force remains the same. If you took a piece of wood and immersed it in water, and a similar piece in mercury, you will notice that because the density of water is less, more of the wood will be submerged in the water than in the mercury. So the amount of water displaced will be less than the amount of mercury displaced. But if you weigh the water displaced and the mercury displaced, you will realize that they will weigh the same. That means that the buoyant force on a floating body will be the same, regardless of the density of the fluid. A body floats when its weight is equal to the buoyant force. In case of light wood, the wood that is submerged in the water is less. Therefore, the buoyant force is less. This buoyant force is equal to the weight of the light wood, and hence it floats. In case of heavy wood, the wood that is submerged in the water is more. Therefore, the buoyant force increases. This also matches the weight of the heavy wood, so it floats. In the case of steel, the weight of the steel is greater than the buoyant force, even when the bar is fully submerged, so it sinks. Air is also a fluid, and therefore all bodies in air will experience a buoyant force. Since the density of air is very small, the buoyant force is also very small. The water balloon weighs more than the same volume of air. So, although a buoyant force acts on it, it moves down. A helium balloon weighs less than the same volume of air. So, the buoyant force is higher than its weight, and the helium balloon moves upwards. Suppose a piece of steel weighs 60 kgs in air. Now, place it in a tray of water while still attached to the scale. Because the buoyant force of water will act on the scale will show a lower reading, say 40 kgs. That means it shows 20 kgs less than the real weight. This difference of 20 kgs is on account of the buoyant force. The apparent weight of the steel piece is now 40 kgs. If the steel was immersed into a mercury batch instead, the buoyant force would have increased since the steel is completely immersed, and the apparent weight would be lower than that in water. Archimedes' principle states that a body will float when the weight of the displaced fluid is equal to the weight of the body. The wood floats since it satisfies the Archimedes principle, and steel sinks since the weight of water displaced is less than the weight of the steel piece. Atmospheric pressure is the pressure that we experience on account of the column of air above us. On the top of a mountain, the atmospheric pressure is less, since the column of air above us will be of a lesser height. When there is a vacuum in the tube, and the tube is lowered into a bath of mercury, the atmospheric pressure on the bath will push the mercury up to a level of 76 centimeters. This is a very convenient height, and therefore mercury is used in manometers. If there is air trapped in the tube, the air pressure will reduce the level from 76 centimeters depending on the pressure inside. If water is used instead of mercury, the same thing will happen. But instead of a height of 76 centimeters, water will rise to a height of 1033 centimeters, which is not practical. Therefore, water cannot be used in manometers. A pump sucks the air from the top of the tube, and that causes the water to rise up. Since the maximum the atmospheric pressure can push the water up is by 1033 centimeters, even though all the air is removed by the pump, the water will not rise above 1033 centimeters. So, if you want to dig a bore well, you must ensure that the water level is less than 1033 centimeters below the ground. Consider a U-tube with the closed left limb having trapped air and the right limb open to the atmosphere. When air at atmospheric pressure is trapped in the left tube, then the two levels of water in both arms will be equal. When air in the left tube has a lower pressure than atmospheric pressure, the level in the right arm will be less than that in the left arm. Similarly, when air in the left tube has a higher pressure than atmospheric pressure, the level in the right arm will be more than the left arm. Two arms of a U-tube have the same level of water. Kerosene, which has a lower density than water, is poured into the left arm. Now, draw a horizontal line from the point where the water and kerosene meet and measure the heights of the kerosene and water arms from this line. The ratio of the heights of the kerosene and water is the same as the ratio between the densities of water and kerosene. Initially, the U-tube has mercury in it. Kerosene is poured in the left arm and water is poured in the right arm. The liquids are poured such that the level of mercury in the two arms is the same. The ratio of the heights of the kerosene and water is the same as the ratio between the densities of water and kerosene. Boyle's law states that pressure and volume are inversely proportional. If the volume is doubled, the pressure is halved. If the volume is halved, the pressure doubles. The equation of continuity states that the area and velocity of a pipe are inversely proportional. If the area of a pipe is doubled, the velocity halves. You can use the slider bar to try out the velocities for different areas. Bernoulli's principle is that the area and pressure of a pipe are directly proportional. If the area of a pipe is doubled, the pressure doubles. So, this also means that when the area of a pipe is increased, the pressure increases, but the velocity decreases. Similarly, if the area of a pipe decreases, the pressure decreases, but the velocity increases.